Okay, hello. I'm going to make a video on stalls. I made a previous video, but I don't think I'm going to upload it because I think I can do a better job at explaining it. And stalls are very important, especially for a beginner student, so I'm just going to go ahead and see if I can elaborate on this better. Now, the concept of stalls you'll be taught very early in your flight training, and your instructor may or may not do a very good job at explaining it. And I know that some people find it as a point of a point of anxiety during their training, which understandably so, because you're very new to flying as is. You understand that the plane is pretty much in the air, so you're still kind of getting over the fact that, oh my god, it actually flies and it's not going to fall out of the sky and kill me and everybody on the ground. And then right when you're barely getting over that, you go out and do stalls, and then it shows that everything you thought you knew about aircraft or flying was a complete lie. In fact, I gotta say that happens very many times in your aviation career. You're gonna have very many experiences where you suddenly figure out that everything you thought you knew in life was a lie, and that actually happens more than once in your lifetime. So get used to it. Anyway, let's get started. So, okay, stalls. Now, the reason stalls work is we'll go back to my previous video about lift turning tendencies and that concept of flight. So here's my airfoil again. And in fact, I really wish that they made one of these where I could just kind of like put it on there. I don't know, I might need another program to draw this stuff. But okay, so let's go ahead and start talking about stalls. Now, we already know how lift is formed. You have airflow going over your wing, opposite and parallel to your flight path. So there we go. So we got it over, we got it under, got it over, we got it under, and then of course we got the airflow that's undisturbed. So basically this is how our lift's being developed. Oh, and of course we got the lift turning tendency at the bottom. So that's our wing generating lift. Now we already know that your angle of attack, your stall is based off of your angle of attack. Your angle of attack being the angle between your relative wind and your chord line. And I'm pretty sure this isn't the first time I've said this, however, I'm saying it again. It's the angle between your relative wind and your chord line. So angle of attack is the angle between the relative wind being opposite and parallel of the airfoil's flight path, and your chord line. Okay, so this angle right here, in case you're not sure exactly what that is, again, your angle of attack is the angle between your chord line and your relative wind being opposite and parallel of your flight path. That's very important. Hopefully hopefully I drove that point home. Okay, so what does that mean? Well, your angle of attack, now let's just say this is a pretty conservative angle of attack, so it's like 0 to 3 degrees, if you will. Okay, and we'll keep it pretty conservative. Well, what happens as you increase your lift, you increase your angle of attack? Well, what's going to happen is, one, you'll generate more lift because your coefficient of lift is based off of your angle of attack, among other things, but it can best be thought of angle of attack. So what we'll do right here is we'll draw the airfoil in the same spatial orientation to us, but we'll redraw where your relative wind's coming from. And in this case, we'll make your relative wind coming up pretty much at a 45-degree angle, if you will. So then what do we have here? What we have is we have your chord line and your angle of attack. So now your angle of attack between your relative wind and your chord line is increased. Now, I'm not exactly sure. I'm not about to, this is like basically crayon painting right here, and I'm not about to pull out a protractor, but let's just say that your angle of attack here is about 6 to 8 degrees. And I guess that would work right there. So 6 to 8 degrees. Well, what happens? Well, what winds up happening is when you start, you might still be completing your full lift potential, if you will, but what happens is that you're going to start affecting the airflow, flowing over the top of your airfoil right here. And primarily what we talk about with that happening is as you increase your angle of attack, what happens is you're going to start having the airflow is going to start having a problem where it's not going to be able to complete the journey, if you will, over the top of the wing and then go down towards the bottom. So what you're going to wind up having is it's going to go till you have a point of separation, probably like right there. And then what happens is you're going to go from laminar airflow to turbulent airflow. And then if you don't know the difference between laminar and turbulent airflow, then we'll go ahead and I'll make another video explaining that. Now at this point you're still generating lift, but you're generating a lot of drag, and this turbulent airflow right there is going to generate a lot of drag. But then let's go ahead and continue on with this and see what happens. Now let us increase our angle of attack here to our critical angle of attack, which generally is 16 degrees. So let's just go ahead and draw our 16-degree angle of attack, which I think previously that's what we were looking at. Let me see. That's my buddy. Okay, I have to call him back. Sorry, Sky. So here we go. So here is our critical angle of attack right here. There's a chord line. There is our critical angle of attack. So let's just say that's right at 16 degrees. Okay. So what's happening to the airflow? Well, at the critical angle of attack, what you're having is you're having a point of separation well. Hang on, let me see. You're having a point of separation that's well in front of your airfoil, probably like right here. And what happens is you just converted all that lift that you're generating into drag. Okay? Because two things are happening. One, your pressure differential is shot. You don't have that anymore. And you definitely don't have the turning tendency anymore because your turning tendency is going from here to down there. So then you lose your lift and you basically fall out of the sky. Now, how do you recover from a stall? Well, it's easy. All you do is you drop the nose, resume airflow over the wing, resume your speed, and then bring your nose up to level. Nice, smooth, coordinated movements. Okay? Now, in my next video, I'm actually going to talk about the boundary layer and talk about the science that happens behind this actually happening, or this problem right here, or why the stall actually happens. But hopefully this will explain the stall in a little bit better detail. But remember, what I want you to remember is the stall is based off your angle of attack between your chord line and your relative wind. Okay.